Hey there, universe nerds. When you look up at the night sky, you see stars scattered randomly across the darkness. But if you could zoom out, way out, far beyond galaxies and clusters, the universe would look very different. Instead of random chaos, you'd see a vast network of filaments and voids, a structure so large and intricate it's called the cosmic web. This is the hidden skeleton of the universe, and today we're going to explore what it is, how it formed, and what it tells us about the cosmos. The cosmic web is made up of galaxies, clusters, and dark matter arranged in long filaments stretching hundreds of millions of light years. Between these filaments are enormous voids, empty regions where very few galaxies exist. Together, the filaments and voids form a pattern that looks strikingly like a web or a sponge. This is the largest structure we know in the universe, far bigger than any single galaxy or cluster. It's the architecture of the cosmos itself. So how did the cosmic web form? It all goes back to the Big Bang. Tiny quantum fluctuations in the early universe created slight differences in density. As the universe expanded, gravity amplified those differences. Matter flowed into denser regions, creating filaments, while emptier regions became voids. Over billions of years, these filaments grew thicker and longer, forming the vast web we see today. It's like the universe slowly sculpted itself into a giant three-dimensional pattern. Dark matter plays a starring role. Although invisible, it makes up about 85% of the universe's matter. Dark matter clumps under gravity, pulling in gas and forming the backbone of the web. Galaxies form along these invisible filaments, lighting up the structure. Without dark matter, the web wouldn't exist. The universe would just be a thin soup of scattered stars. Astronomers have actually mapped parts of the cosmic web. By surveying the positions of millions of galaxies, they've revealed the filamentary structure. Even more impressively, scientists have detected hydrogen gas glowing faintly along the filaments, confirming that they're real physical structures, not just statistical patterns. In 2014, the first direct images of the cosmic web's gas filaments were captured, a milestone in cosmology. The cosmic web also helps explain cosmic evolution. Galaxies don't just float randomly. They migrate along the filaments, merging and clustering where filaments intersect. These intersections are home to the largest galaxy clusters, cosmic cities containing thousands of galaxies bound together. In a sense, the cosmic web is like a highway system for galaxies, guiding their growth and shaping their destinies. And the voids? They're just as important. These enormous empty regions can stretch hundreds of millions of light years across. They act as cosmic laboratories, where the effects of dark energy can be measured more clearly. The balance between filaments and voids reveals how fast the universe is expanding, and maybe even the true nature of dark energy itself. What's most mind-blowing is the similarity between the cosmic web and other natural patterns. When scientists compare maps of the universe with networks of neurons in the brain, the resemblance is uncanny. Both systems show nodes connected by filaments. Both balance efficiency with complexity. Of course, the universe isn't literally a brain, but the comparison is a reminder of how nature loves repeating patterns at every scale. So is the universe really a web? Absolutely. At the largest scales, galaxies are not isolated. They're threads in a grand tapestry woven by gravity and dark matter. The cosmic web is the closest thing we have to seeing the skeleton of reality. And every time you look at the stars, remember, they're not scattered randomly. They're part of a cosmic pattern stretching across billions of light years, a structure so vast that our entire Milky Way is just a single speck in its threads.